Well, thanks everybody for taking a little time at, here on the East Coast, the end of the day, but certainly after all the presentations to come just learn a little bit about JMP statistical software. So my name's Ross. I'm an academic ambassador for JMP. So I basically just help faculty who teach with JMP get what they need out of it. But I've also previously taught statistics with JMP specifically in psychology programs. So to psych undergrads, and I really found it to be a pretty valuable tool in helping students just develop better intuition for statistics concepts. And so that's what I'm hoping to share with you today, is just some tools to make stats more accessible. And then really we're going to be focusing on interactive visualizations. I have a feeling at least a fair number of people here may have not seen JMP or really know anything about it. So I'd like to just start very broadly with what JMP is. So I'm actually in JMP right now. This window that you're seeing is just what we call a JMP journal. It's essentially like a virtual notebook for the analyses you do. JMP software it's desktop statistics software. And what we think makes it a particularly strong teaching tool is its highly interactive and visual nature, which we're going to focus on almost exclusively right now. And it's also no code. So students can point and click their way through everything that they do, though there is a scripting language underneath for those folks that actually would like to do some coding or maybe script some things or automate things for their students. So I'd like to just give you an idea when I say it's visual and interactive, what I mean by that. So here's some data that we're going to work with. This is from the World Happiness Report that is issued by the United Nations and is conducted in collaboration with Gallup polling. So these are data from 2019. These are real data. You can go download them. We have data on 138 different countries. We have average reported happiness of individuals polled in that country on a 1 to 10 scale. And we have a number of other variables that might relate to their happiness. For example, the GDP per capita in that country, the life expectancy, and some other variables derived from survey responses. For example, social support is just the proportion of people who reported having somebody in their life that they could count on for immediate help if they needed it. So we'll explore these data right now, just to give you a preview of JMP and kind of how it works, what might make it a good teaching tool. Everything that you do in JMP is going to come bundled with some kind of interactive graphic that makes exploring and understanding statistics a little bit easier. For example, if we just look at, let's say, a couple variables and just assess their distributions right off the bat, we receive interactive graphics that allow us to start exploring relationships between our variables. For example, I'm noticing that if I select just the really high happiness countries, already the European countries are spiking on the left. Or even just maybe adjust the width of my histogram bars to try to get an idea of what the true shape of that distribution might be. So JMP analyses come bundled with these interactive graphics. They're also great tools for just building graphs and graphical exploration. For example, if I wanted to look at the effect of social support on happiness and maybe even bring in the region of the world that we're talking about, creating a graph to explore these three variables in conjunction is pretty simple. And these graphs, as we'll see, are interactive as well. You can see those points being selected back in the data table. And we're going to see some ways in which that's actually can be in the right hands, particularly useful in teaching. Can even make statistical models more accessible. So here I have a multiple regression model where we have two variables predicting happiness, and I can actually use a 3D visual to explore the shape of that model. So we fit a plane to our data that's showing some twisting, suggesting an interaction. Now we're going to take a look at everything I just did in a little more detail. I'm just trying to give you an idea for what JMP is and how it's designed. Just to give you an idea of the capabilities. So really, what can you teach with JMP? It's a pretty wide tool. So if I pull up this starter window, as we call it, that summarizes tools, you'll see on the left all the different categories of things, and on the right, the various analytical tools. In our keynote earlier today, we actually heard a little bit about how it's important to maybe teach the front end of analytics of data science. So getting from raw data to tidy data. JMP is a full-featured tool for actually structuring your data, getting it ready for analysis, and then performing basic analyses. So for example, your t-tests, or maybe your simple regression or your chi-square tests, building any range of different regression models, teaching design of experiments, maybe getting into particularly advanced topics like principal components analysis or other multivariate techniques, or teaching what we might call machine learning. So that could be clustering or predictive modeling, say with neural networks or decision trees. JMP is a pretty wide tool, so you can use it to teach anywhere from your really basic introductory level statistics through advanced graduate topics. Now, before we dive in, I do want to highlight that in addition to providing software, JMP provides an entire team that's devoted to helping academics, helping teachers get what they need out of the tool. That's where I come from, the JMP Academic Program. We provide a lot of free resources and services for stats teachers. So if I go to jmp.com/academic, you can find the JMP Academic Program homepage, where then I could click on Learn how we help faculty to find more information. So on the left, you can find information about why one might want to use JMP. On the right, information about how you might get JMP. There are multiple licensing options available, including an option for students to just purchase JMP directly for $30 online, so that no larger license is required. But particularly important is this middle link to all of our course materials. In conjunction with university faculty, industry practitioners, and then also JMP staff, we develop a lot of course materials totally free of charge to help complement your course if you use JMP to teach it. So for example, I just clicked on introductory statistics, where I can find books that use JMP to teach intro stats. I could go to our learning library of step-by-step guides. These are quick videos and one-page guides to summarize how to actually just do things in JMP so that you don't have to spend a ton of time teaching it. For example, if I were to click on the dot plots here, if students are making dot plots in my course, they'll find just a brief, about 2-minute tutorial video walking them through it, and a PDF guide that they can take for reference. So we have over 100 of these entries in this learning library to help instructors actually teach JMP the tool so they can spend time teaching the statistical concepts. Another particularly popular resource is our case study library right here. So these case studies, of which I think we're approaching maybe 60 now, and more are in development, are real-world data analysis problems, complete with sample data sets that walk students through a problem setup, multi-step solution path, including screenshots and instructions for doing things in JMP. And then finally, at the end of each, some additional exercises for them to hone the skills that they were working on. So this is another particularly popular resource that we have. And of course, if we scroll down, we can see we also have lab activities, some teaching applets, which we'll take a look at today, sample data sets, even a webinar series aimed exclusively at academics. And we also offer free one-on-one consultations for your course or how to do something in JMP, classroom presentations, group workshops, if you, let's say, have other colleagues that would like to learn how to do something in JMP, and always totally free of charge. We're just a team at JMP that tries to make sure that people who use JMP in their teaching get everything that they need so that they can be effective. So I did just want to highlight the JMP Academic Program before we actually take a more detailed look at the tool. I see one question came in the chat. Can we use JMP for teaching process control? Yes, JMP has a suite of statistical process control tools, so you would be all set there. So now let's talk about making stats accessible with interactive visuals in JMP, and we'll go back to our world happiness data from 2019. What I think at the outset we probably just started to develop an intuition for is that graphs in JMP are not static images. They are interactive tools that we can use to explore data and in the hands of a skilled educator, we can use them to explore actual statistical concepts themselves and make them a little more intuitive for our students. Perhaps the most popular tool with respect to interactive graphing in JMP is the graph builder itself, which we saw very briefly. So let's see it in a little more detail now. So it lives at the top of our graph menu because it's a robust general purpose graphing tool. And it functions with drag and drop interface. So you can see I have a list of the columns in my data table or my variables on the left, and then I have this blank palette on the right, and I can just drag variables into that palette to build a graph. So if I'm in an educational context and I just want to start exploring what relates to happiness, I might put happiness on my y-axis and then just pick one of these variables. We've been talking about social support, so let's stick with that. Put it on my x-axis, and immediately I get a graph. In this case, it's a scatter plot with an element that we call our smoother. So this is essentially just a spline fit through here to give us an idea of what the trend is. I can select any kind of graph I want, though. I might go with the line of best fit, so a simple regression. I might actually ask for a density ellipse just to get an idea of the correlation. And students can actually explore all of these different options to try to find a graph that helps communicate to them something meaningful about the data. Now, what we did before is we actually grabbed this other variable, region of the world. We might want to know if we're a student, well, okay, I see this positive relationship between happiness and social support. Does that vary across the different regions or not? And what's nice about interactive graphing, as it's done in Graph Builder, is that doesn't involve maybe conceptualizing, well, what graph might tell me something like that, and how would I go about creating it? Do I need to back out and maybe go to a different dialogue or something like that? Well, you can actually just grab region and just start dropping it into various places in your graph until you see something that is meaningful to you. And so this takes data visualization and exploratory analysis and makes it just something a lot more accessible, where students can just essentially play in this visualization playground until they find something that actually helps them better understand the relationships between all these variables. In this case, I've just created a trellis plot. So I have 4 different regression lines, one for each of the 4 regions. And I can see that the slopes of these lines are a bit different. So maybe this effect of social support on happiness varies in different parts of the world. So let's actually remove that now. There are a number of other ways that the interactivity, if you know how to use it well, can actually be really illuminating to teach even just statistical concepts. So I'm going to tick the equation box here. So now we have up in the top left, I actually have the regression equation. Oops, sorry about that. Let's get the right. There we go. So it looks like the slope of our line is about 6.9. So across our range of social support, which varies from 0 to 1, we would expect a rise in nearly 7 points of reported happiness. So it seems like a pretty big effect. Now, if we're just talking, let's say, introductory statistics, we might say, okay, the slope of the line corresponds to this value right here. But of course, we know that in graphing, even just choosing your axes matter. Well, in JMP, the axes themselves are elements that you can interact with. So you might say, well, but what if we actually just change the axis to represent the full range of possible values? Okay, well, now that looks like a relatively strong effect, but maybe not as much as it did before. Of course, if I wanted to try to stress this effect, I could change the axis this way. And so here we're already now communicating just through really simple element of interactivity, the fact that, well, the perceived slope of the line and the actual slope of the line, they're not necessarily connected, and we need to really pay attention to what scale we're using. Just one example of actually just using some simple interactivity in a graph to help teach a statistical concept to make it a little more intuitive here. Now, if we were using this graph, I'll click done to get the controls out of the way. We might also talk about how in regression, points that are really far out in our X space, so maybe all the way out here, are high leverage. They exert a lot of influence over the ultimate slope of the regression line. We could use some interactivity to help make that concept more intuitive as well. I'm going to pull up this tool called a local data filter in JMP, which allows us to filter our data according to any criteria we want and have any analysis or graph automatically update. So let's actually just filter on social support. And just to make it easier here, I'm going to lock our scales into place. And we can actually see what happens as I start to filter out those low social support values. And if you look at that equation, now we're watching that slope rise quite a bit. And so those points out on the left do seem to be exerting an influence, and they're actually kind of causing the slope to be a little more shallow. In fact, maybe we wonder if we have a curvilinear relationship that looks more like this than a straight line. Just another example of using some of this interactivity to try to help make a statistical concept, in this case, leverage, a little more clear. Now, you may have noticed this before when I selected some points early on, but in JMP, all of the graphs and analyses are linked together. For example, if I just start selecting points here, you can actually see that they're being selected back in the data table. The fact that multiple visuals get linked together can also be pretty valuable in teaching stats. So if I go to Graph Builder and let's say make a graph of, we'll do social support by region, given that we think social support affects happiness, we want to see if it varies geographically. And so I have a simple dot plot. I might notice, for example, I have 2 points over here in Europe that seem to be a little low in social support. And now that I've selected them, you can see that they're selected over here as well. In fact, I might choose to, I don't know, let's make them red, and we'll make them a different shape too to help make them stand out. And so we see, okay, well, yeah, these are maybe low outliers for social support for Europe, but it looks like they follow the trend that we're seeing pretty generally. So the fact that everything gets linked together in this way is just another way to help students start to make connections, in this case, across multiple visual representations of the data. It'd be pretty hard to do this without this level of interactivity. So as mentioned at the outset, in addition to Graph Builder, all of JMP's analysis platforms, they come with interactive graphs as well. If we look at this tool, distribution, for example, we will see, let's just do happiness and we'll do social support and region, that we get these interactive histograms and bar charts in this case. And this is part of the kind of design philosophy of JMP, a graph with every analysis, and that graph should be interactive. So again, as I've selected some of these points here in high happiness, I can see, oh, they are piling up at the higher levels of social support. So there might be a relationship there. And it also looks like Europe and maybe the Americas have a relatively high proportion of countries reporting higher happiness here. Now, of course, we saw before with interactive axes and other things that the interactivity often goes beyond actually selecting points itself. One of the things I like to do is pull up the hand tool when I'm dealing with histograms, and then you can actually just interactively change bin widths to help students understand that bin width in a histogram is a choice, and the choice that you make can either reveal or obscure different patterns. For example, looking at a histogram like this, we might know that what we're looking at is a lot of noise here. If we were to say, fit continuous distributions to this to try to find a good fit, here we have one, in this case, it's a Weibull distribution. Well, it looks like if this is the true underlying distribution, and that's maybe our best guess, that this histogram is actually very noisy. And of course, if we were to choose a bin width that looks like this, maybe it's not presenting enough detail. And so maybe we would think, oh, somewhere, I don't know, around here is where the histogram starts to more faithfully represent the actual shape of the distribution. And so again, our graphing choices matter, and we can explore this through some interactive features here. If you were at the talk that I gave earlier today, we talked a little bit about, let's say, teaching residuals. So just to give one more example of these built-in graphs in analysis platforms, if we were to look at, say, the relationship between, let's do happiness and positive affect, where positive affect is just an aggregate measure of different reports of people feeling things like happiness, joyfulness, gratitude at some point recently. So here we're in a tool that allows us to fit a simple regression line and get the corresponding statistics out We can actually see the 2 points that we made red diamonds earlier hiding in there, those 2 European countries. And now if I wanted to teach students, let's say about residuals, as we talked about in the talk I gave earlier, I might go ahead and pull up a residual plot. So I'm going to actually just close a few of those and just focus on this residual by predicted plot right here. And so what we want students to understand in this case is that in a residual plot down below, we have that line at 0. Residuals reflect, the distance between a point and the line. And so negative residuals means below the line, positive residuals mean above. We can use interactivity to make that a little more intuitive. So for example, I might just actually select all the negative residuals and we can just see those get selected in our regression graph. There they are. Those are the points that lie below the line. These positive residuals, these are the points that lie above the line. Just another one of the many possible uses of interactive visuals to help make a stats concept just a little more accessible or intuitive. Now, for many of us, if we teach intro stat, getting to something like a simple regression might be the end point of the course. But I'm sure a fair number of us might go a little bit further, maybe teach something like multiple regression, or if we're in, say, business analytics, I know it's quite common to start teaching things like decision trees or neural networks. And when we build larger scale models, that's where it can get really hard to understand what's going on and where these interactive visuals shine even more, I think. We have a tool throughout JMP, it's called the profiler, and it basically just turns statistical models into something that you can see and touch and probe. So I'm going to go to our general purpose regression tool. I'm going to put happiness in as the Y, and we've been looking at social support and positive affect. Let's look at the main effects and just the two-way interaction for those. So I've run a regression model. Of course, I get my parameter estimates out, and it is pretty important for somebody studying multiple regression to be able to interpret these. But what is, especially let's say for that interaction value of 11.8, what does that really mean? Well, we can use a tool like the profiler to illustrate that. So here I have one pane for each of the 2 effects, or 2 factors, I should say. We have 3 effects in our model. What we have is social support and positive affect. Each one is essentially a cross-section of the response plane at the particular value of the other variable. And then we have the model's predicted happiness on the left. And so I can see, well, it looks like a pretty steep effect of social support. I can see how happiness is decreasing as I go down or increasing as I go up. And crucially on the right, if you look, I can see the slope of that regression line for positive affect change. So what does this positive parameter estimate up here mean? Well, it means that the effect of one variable gets bigger as the value of the other variable goes up. As social support goes up, the effect of positive affect gets big. As it goes down, it actually cancels out. We saw at the very outset that we can profile in 3 dimensions as well. So here we have our surface profiler, or if I can just make that a little bigger, and we'll even add the original points, we can actually see evidence of that interaction in the plane that we can explore just by spinning this here. So that twist, seeing that at low levels of social support, the effect of positive affect is almost nil, but at high levels of social support, it's relatively strong. So these profilers, when you get into larger modeling, can be really, I think, invaluable in helping kind of demystify all of this stuff of the models that we're actually making. Now, to close up, I want to highlight that in addition to the various interactive visuals when performing analyses in JMP, JMP includes a range of built-in teaching applets and simulations that can help make abstract stats concepts more concrete. And perhaps you've seen some of these around. I mean, not even necessarily in JMP, but I mean, these kinds of applets and simulations are quite common. You'll notice I have a student menu up here. This is actually built into the JMP student subscription, which is a form of JMP any student can just buy online for 30 bucks, as I mentioned before. You can also, if your institution licenses JMP, the standard version, you can just install this using an add-in. And in the student menu, you're going to find, among other things, a number of applets for demonstrating statistics concepts. So we've been talking about regression. So let's look at the regression demonstration. So here I have the ability to specify an underlying regression model that generates my data. So I can manipulate the intercept or the slope, the correlation, or the amount of error, and reveal what the true line is that generates it. So there it is. And then, of course, fit a simple regression line to it. Oh, I did not want to fit my line. Let's fit just a regular regression line. So here's the output we would get if we actually fit that in that tool we just saw. I'm going to hide that for now. We can see that, of course, that regression line doesn't actually hit the true line. And if I were to get a different sample, it again doesn't hit the true line, but looks a little different than it did before. And again, different than before. So imagine now we're trying to teach students about the regression envelope or the confidence interval around the fit, which we know looks something like this typically. Well, where does that actually come from? Oh, I actually just added an additional point, which you can see is another thing that you can do here. And I'm even using that to pull the line around. Well, down below, we're actually collecting all of these regression lines that we fit. And so I can see that as I collect more and more, that interesting almost butterfly shape of the regression line starts to appear. In fact, let's go ahead and just pull, I don't know, 5,000 regression lines. And now we can kind of get a better idea about how that envelope around the regression line captures some uncertainty about where that true line is. And this is done in a more interactive and visual way than we really might be able to do without a tool like this. So you may have noticed there are a number of these teaching applets. Let's take a look at just one more to boost your intuition for the types of things that are possible here. Here's one to demonstrate the sampling distribution of the mean. So for most of us in intro stat, at some point, we're going to cover the central limit theorem. So let's go ahead and sample from a population that is skewed hard to the right. Let's sample, let's say 50 points. And I'll draw one sample and then down below plot the mean that I obtained, which in this case was 101.5 almost. And so I can start to plot more and more sample means, or even animate the collection of, let's say, 100 here to see how we start actually building the sampling distribution of the sample mean over, potentially infinite samples. In fact, if let's say we do 10,000, I won't bother animating that, and maybe plot a normal curve on that, we can see, oh, wow, okay, so even though this population we're sampling from is really hard right skewed, we're starting to get a very normal looking distribution for our sampling distribution. So JMP comes bundled with a number of these tools. Again, you can get this student menu into any version of JMP or just go straight to the student subscription to find it. So we have applets, statistical calculators, and a number of other demonstrations as well, all for teaching purposes. So that's all I really wanted to show you about JMP today, and just kind of give you an idea for how a tool like this can be used to make statistics concepts more accessible. Again, I'm here representing JMP right now. I also did teach with JMP for a while, and it really did find it particularly helpful for some of these where you finally you see a student have that moment where it finally makes sense. And we just hope to help more students have those kinds of moments. Feel free to check out jmp.com/academic if you want to learn anything more. Shoot me an email. Here's my email address right here. And then I'm also hanging out at the JMP booth. So feel free to connect with me there as well. So that's all I got.
Does anyone have any questions?
I see some questions coming in.
Yes, so we have...
do you have non-parametric analysis tools in JMP? Yeah, we have a variety of non-parametric analyses as well. Feel free to connect with me if you want. I can tell you about any specific ones you're interested in. Somebody asked, did you teach college stats or AP stats? I taught college stats. So both intro level and then also an honors sequence on design of experiments and advanced regression modeling. Somebody said, which JMP are you using? How does it differ from the institutional JMP? I'm right now running JMP Pro 16.2. Nothing that I showed you is in JMP Pro. It's all standard JMP. JMP Pro just has some more advanced analytical features. So if you have institutional license for JMP, you should have access to this specific version that I'm using right now. And feel free to shoot me an email if you have more questions about that. I can help you figure out which version you have access to and who you might want to contact at your school. Feel free to come by the booth, chat JMP, or just teaching stats. We don't have to talk about JMP. I'll be around.
All right, thank you very much. I hope everyone has a great rest of their day. Bye-bye.
Bye.